Ever get that feeling that, what you see isn't really everything?
Oh, absolutely. That sense that the solid world, objects, even ourselves as separate
Yeah,
beings.
it feels so real, so intuitive.
But what if that intuition is just sort of scratching the surface? What if reality is fundamentally, well, less separate and more fluid?
Exactly. And that deep question is what we're really diving into today. We're exploring the shift from quantum mechanics, QM, to its successor, quantum field theory, or QFT.
And then, crucially, how this move from particles to fields might open up new ways to think about, well, spirituality.
Right. We're drawing on some interesting work here, ideas from Jeffrey L. Taylor's writings connecting quantum field theory and spiritual dimensions. He really tries to bridge physics and these bigger philosophical questions.
It's a bold connection to make. So our plan is, first, let's really nail down this core difference. Particles versus fields. It's fundamental.
Yeah.
Then we'll look at how QFT seems to just dissolve some of the really thorny paradoxes in QM.
The ones that make your head spin a bit.
Those are the ones. And finally, we'll explore these, frankly, surprising parallels between a field-based universe and some very old spiritual ideas about reality.
Sounds like quite a journey. Okay, well, let's start with that big idea, the illusion of matter. It seems like both science, QFT specifically, and many spiritual traditions, you mentioned Hinduism's Maya, Buddhism, others too, they all kind of hint that matter isn't what it seems.
It's a striking convergence, isn't it? But they get there differently. Science, as Taylor points out, relies on repeatable experiments, right? You test things, you verify.
The whole scientific method, yeah, rigorous testing.
Exactly. Whereas spiritual traditions often talk about repeatable inner experiences, consistent insights gained through things like meditation across cultures and times. And one recurring theme is this idea that the physical world isn't the ultimate reality.
Like two paths leading to a similar viewpoint. It reminds me of Plato's cave allegory you brought up from the source.
Precisely. Millennia ago, Plato used that image of prisoners mistaking shadows for reality. It's such a powerful metaphor for limited perception.
And the prisoner who gets free and sees the real world, that's like the spiritual goal of seeing beyond the senses, using the mind.
That's a great way to put it. Transcending sensory limits to grasp a deeper reality. It's about realizing the shadows aren't the whole story.
Okay, so if matter, the solid stuff,
Yeah,
isn't the foundation, what is? This must be where the particle versus field thing comes in.
exactly. Our everyday intuition is all about particles. Little bits of stuff, localized, having a position, moving around. That's materialism, basically.
A table is made of atoms, atoms made of smaller particles, like tiny building blocks.
Right. And Taylor defines particles just like that. Localized, with location and motion. From quarks to planets, it's the particle picture. And it works really well for a lot of things.
But then fields, that's where my intuition gets a bit shaky. How are they different?
Well, fields aren't localized things. They're spread out everywhere throughout space. A field assigns a value like temperature or force to every single point in space.
Ah, okay. So not a thing in space, but a property of space itself.
You could think of it that way. Like an electric field around a charge, it fills the space, and it affects other charges in that space. It's pervasive.
And the strength can vary, right? Stronger closer to the source, weaker further away.
Exactly. That variation is key. It's a continuous entity, not a discrete object.
And this challenges that model of the atom we all learned, the one with electrons orbiting like planets.
Oh, massively. Taylor makes a great point about that diagram. It's been known to be wrong for, like, a century, but it sticks in our heads.
Tiny solar systems, right?
Yeah, and it's misleading in so many ways. First, the scale is way off. Atoms are almost entirely empty space. If you took out all the space in our atoms,
We'd be microscopic, like a grain of sand, wasn't it?
something like that, yeah. Staggering. And electrons don't orbit. If they did, they'd radiate energy and spiral into the nucleus instantly. Matter wouldn't be stable.
Okay, so no orbits. What are they doing then?
It's more like a probability cloud. A region where the electron is likely to be found if you measure it. It's described by quantum mechanics, but even that's rooted in a particle view.
And the nucleus isn't solid either. You mentioned EMCA.
Right. Mass is energy. The nucleus is incredibly concentrated energy. Particle accelerators smash things apart, and fundamentally, we find energy in fields, not tiny solid bits.
So if you keep asking, what's it made of?
Yeah.
Like that 5-year-old scientist analogy in the source.
Yeah.
You go from person to cells to molecules to atoms to electrons.
Yeah. And then
Matter.
you hit the electron field, and if you ask, what's the field made of?
Silence. That's the fundamental level, as far as we know now.
According to our best theories, yes. Like physicist Frank Wilczek said, particles are really just secondary effects. The quantum fields are primary.
Okay, fields are primary. But what is a field, conceptually? The source used an analogy, right? Like balls and springs.
Yeah, that's a good way to visualize it. Imagine one ball on a spring, bouncing. Now imagine an infinite mattress of these, all connected. That's like a quantum field filling space.
An infinite bouncy mattress.
Sort of. And if you push down on one spot, it creates a ripple, a wave that travels across the mattress.
Ah, and that ripple, that disturbance, that's the particle.
That's the QFT picture, yes.
Mm-hmm.
A particle is an excitation, a quantized vibration of the underlying field. It's not a separate little thing.
And these fields follow quantum rules, right? You mentioned two main ones.
Yes. First, they're never perfectly still. There's always a minimum jiggle, even in empty space. Quantum uncertainty.
Constant motion, okay.
Second, quantization. The energy of the field's vibration can only exist in discrete steps, like rungs on a ladder. You can't have just any amount of energy.
So you need a whole step of energy, a quantum, to make a particle. You can't just nudge it a little bit.
Exactly. You need that minimum quantum packet of energy to create that localized excitation we call a particle.
And this changes what empty space means, too. It's not empty.
Not in QFT. Even a perfect vacuum devoid of particles is filled with these fields constantly fluctuating, constantly jiggling with that minimum energy. It's called vacuum fluctuations.
Wow, so the vacuum is actually alive with activity.
In a quantum sense, yes, it's a sea of potential. The particles we see are just the bigger waves on that sea.
And these field vibrations explain particle properties, like how they move, interact.
Right. The speed of the ripple corresponds to the particle's velocity, often the speed of light. How ripples scatter off each other explains particle interactions. And wave-particle duality makes sense because the fundamental thing is a wave-like field, but its energy comes in particle-like packets, the quanta.
Okay, this is starting to build a different picture, but you said QM and QFT both give the same experimental results. How can they be so different conceptually?
That's the fascinating part. They predict the same outcomes incredibly accurately, but their ontology, their description of what is fundamentally real, is completely different.
QM started around 1900 with Planck, right? And it's about particles.
Primarily, yes. The Schrödinger equation in QM describes the probability of finding a particle somewhere. It's particle-centric.
And QFT came later, Dirac in the late 1920s, and it's about fields.
Correct. QFT describes how these fundamental fields evolve and interact. The equations describe the field's energy or intensity everywhere. So, same math structure sometimes, but describing fields, not particle probabilities.
And the argument is that the field picture is just cleaner. It avoids the QM paradoxes.
That's the claim. The particle view in QM leads to weirdness. Wave-particle duality, the uncertainty principle, the observer effect. They're hard to make intuitive sense of.
The shut up and calculate approach.
Pretty much. Copenhagen interpretation focused on getting the right answers because the underlying reality seemed so paradoxical from a particle perspective. QFT offers a potentially more coherent story.
Okay, let's tackle those paradoxes. Wave-particle duality first. How does QFT resolve it?
Simply put, in QFT, there are only fields. The fields are wave-like. They extend through space. The particle-like behavior comes from the quantized excitations of the field, those energy packets that act like units.
So it's not that something is magically both a wave and a particle. It's a field wave that has particle-like excitations.
Exactly. The duality dissolves because the field is fundamental. Taylor even notes Schrödinger himself kind of anticipated this field view early on.
Okay, that makes more sense. What about the uncertainty principle? Not being able to know position and momentum precisely.
In QM, it's often tied to measurement disturbing the particle. In QFT, it's more fundamental. Fields are inherently spread out. They don't have a precise single position like a classical particle. The uncertainty reflects the intrinsic nature of the field itself, its fluctuations.
So it's not just about our measurement limitations. It's baked into the field's nature.
More like that, yes. When we see a particle, it's a localized field excitation, but the underlying field is still fuzzy and fluctuating.
And the big one, the observer effect. The idea that looking at something changes it or even makes it real. Schrödinger's cat stuff.
QFT provides an observer-independent picture. Field interactions happen according to the laws of physics, whether someone's watching or not. When a field collapses to produce a particle-like outcome, it's due to physical interactions with other fields or detectors, not because a mind observed it.
So Einstein's bomb paradox or Schrödinger's poor cat, QFT says the outcome happens because of physical field interactions, not because we open the box.
Precisely. It removes that seemingly subjective element and grounds it back in objective physical processes governed by field equations. It's a much less spooky picture, arguably.
Okay, so the universe is made of fields, particles or ripples in those fields. QFT seems more consistent. How does this connect to spirituality then? That feels like a big leap.
Well, think about the nature of fields and information. They aren't material in the clunky classical sense. You can't touch or see a gravitational field directly.
Right? They're invisible, but they have real effect.
Exactly. They carry energy, exert forces, contain information, and we grasp them with our minds, not just our senses.
And this non-material but real nature that resonates with spiritual ideas.
It seems to. Many traditions, especially Eastern ones like Hinduism or Buddhism, talk about a universal energy or consciousness field underlying everything. The idea that our individual minds are connected to or part of this larger reality.
So the question becomes, could there be a fundamental consciousness field? Something akin to what some might call God, or Brahman, or Ein Sof, as mentioned in the source, a primary field from which everything else arises.
That's the kind of profound question this perspective opens up. If the sensory world is an emergent phenomenon from deeper fields,
Then our everyday reality is kind of an illusion, or at least not the full picture, generated by this deeper field reality.
exactly. And scientists and philosophers are speculating about things like consciousness fields or how memory might relate to quantum fields. Research into near-death experiences, ESP, altered states. Some are trying to explore these potentially through a quantum lens.
It's controversial territory, though.
Highly controversial, yes. But the core idea is exploring if consciousness itself might have field-like properties interacting with the known quantum fields.
It's interesting you mention Einstein again here. His idea of Spinoza's God. God is the underlying order of the universe, not a person. That sounds field-like.
It does resonate, doesn't it? And his conviction that reality must ultimately be described by fields is very telling, even if he didn't find his unified theory.
And the field concept itself has a history. Faraday and Maxwell. It wasn't always particles.
Right. Faraday visualized magnetic lines of force, and Maxwell gave them mathematical rigor. It was a huge shift from action at a distance. Fields became real entities carrying energy and momentum, evolving locally according to differential equations.
So physics defines a field as this region with a physical quantity at every point.
Like temperature on a map or the gravitational vector. And these fields have quanta, the smallest bits.
The energy packets, the ripples we call particles.
Yes. Field quanta act like particles because they're exchanged as discrete units, but they are fundamentally excitations of the field. QFT insists the field is primary.
Even if many physicists still think in particles.
Old habits die hard. But QFT, unifying QM and relativity, is our most successful framework. Its implications just haven't fully sunk into the wider culture.
The analogy of color being a property, not a substance, is helpful. Fields as properties of space itself.
It's a good way to think about it. And while there are different fields, force fields, matter fields, the Higgs field giving mass, the key takeaway for our discussion is this fundamental field nature.
And the argument is that this field-based world offers a better place to potentially integrate spiritual concepts, God, consciousness, maybe even afterlife, than strict materialism.
That's the proposition. A world of interconnected non-material fields seems more accommodating to these ideas than just particles bumping around. Some research even tries to link consciousness to electromagnetic quantum effects in the brain, possibly extending beyond it.
Which brings us back to that really striking question. How did ancient traditions, the Vedas, Upanishads, Buddhism, Plato, how did they arrive at this idea of reality being an illusion generated by a deeper energy field millennia before QFT?
It's mind-boggling, isn't it? Science took centuries of complex math and experiments. These traditions seem to have used introspection, meditation.
The power of the mind, essentially. Taylor contrasts Western and Eastern philosophy here, right? West being more dualistic.
Yes, Greek roots often led to splitting things. Mind-body, good-evil, appearance to reality. Whitehead's quote about Western philosophy being footnotes to Plato captures that legacy. This dualism can create its own problems, like trying to grasp a unified whole by dividing it.
Eddington's point about knowing half the world ensures ignorance of the other half.
Exactly. A purely objective, split-off approach might miss the interconnectedness. Eastern thought, like Vedanta, often emphasizes non-duality. Brahman as the single reality, Atman as the individual self being identical to it, The goal is often direct, intuitive knowing of this unity.
And this idea of unity, accessible through the mind, that connects to quantum entanglement.
That's a key link explored in the source. Entanglement shows this profound, non-local connection between parts of a quantum system, like fields. Defying classical separation, it suggests reality is deeply interconnected in ways that resonate strongly with Eastern non-dualistic views.
And entanglement isn't just theory, it's experimentally proven.
Repeatedly. It's one of the weirdest and most profound aspects of quantum reality, and it directly challenges that classical divided picture.
There was also that brief mention of art, Salvador Dali.
Yeah, fascinated by physics. His painting that looks like quantum dots up close but an ear from far away. Maybe artistic intuition tapping into these ideas too. Who knows?
So wrapping this up, QFT gives us a universe of fundamental dynamic fields, not particles. Matter is an emergent ripple.
And this resolves QM paradoxes and surprisingly seems to align with very old spiritual insights about the illusory nature of the sensory world and a deeper interconnected reality.
Which leaves us with that final thought for you, the listener. Could that ancient intuitive knowledge be a form of direct perception of the field reality that QFT describes mathematically?
It's a provocative question. What does a universe made of interconnected fields mean for our understanding of consciousness, spirituality, our place in the cosmos? Something to ponder long after this deep dive ends. It definitely invites us to look beyond the surface.